Okay, so I need to build this API service. Microservices is a good choice for that. Great, I'll let the other engineer know. We'll add something outside the current system. Wait, there's only two of you? Well, for maintainability, I'd keep it inside the monolith. Oh, okay, that makes sense. Yeah, we'll adjust the documentation for the open source community on how to extend it. Oh, wait, open source, external contributors. It should probably be its own platform with a proper extension API. What? What? I'm sure you've been there before. Maybe you've given that answer yourself and watched someone's face fall when you said, "It depends." Well, turns out that's not a quirk of software architects. That's physics. I have a physics degree, and I've spent 20 years in software, and I keep finding that the laws that describe the physical world, they show up in here too. This series is about naming those patterns, so we can use them to make better decisions, recognize pitfalls before they happen, and build better software. You don't need to know any physics. I'll bring the physics, and we can nerd out together. And today, let's talk about some relativity. Or why architecture's most accurate answer is it depends. Imagine you're sitting at a red light. The car next to you starts creeping forward, and for just a moment, you can't tell. Did they move, or did you roll back? You're sitting down. Your body didn't feel anything. The car moved. Or did it? The only reason you can snap out of it is because you have windows. You can see the road outside. You can see the curb, the lane markings, the lamppost that didn't move. External reference points. Those tell you, okay, I'm still. They moved. But imagine that road had no markings whatsoever. No surroundings, no curb. Nothing outside the window but flat, featureless ground stretching in every direction. Now it gets harder. From inside your frame, you're completely still. From inside their frame, they're completely still. Both of those things are equally true. And there's no experiment you can run from inside either car that settles it. When Einstein developed relativity, one of the core insights was this: there is no single true frame of reference. The laws of physics look the same from every frame, but measurements depend on who's doing the measuring. A frame of reference is your vantage point, your position and state of motion from which you observe the world. Every frame has its own internally consistent measurements: time, distance, velocity, all measured relative to where you are and how you're moving. From inside your frame, everything checks out. It's self-consistent and correct. From different frame, the same event produces different measurements, also correct. The one exception is the speed of light. It's the same in every frame, always, no exceptions. Every frame is its own world, but the speed of light is the one thing every frame agrees on. Laws are invariant. Measurements are frame dependent. And it only gets weirder from there. You know how astronauts float in orbit? We call it zero gravity. That's not quite right. Here's what's actually happening. The space station is sitting high above the Earth, and gravity is absolutely pulling it downwards. But the station is also moving sideways and very fast. So fast that as it falls towards the Earth's surface curves away beneath it at the same rate. The station keeps falling and keeps missing. That's what an orbit is. Not escaping gravity, just falling fast enough to keep chasing the curve. Now there's a famous Douglas Adams quote from the Hitchhiker's Guide series: "The secret to flying is learning how to throw yourself at the ground and miss." Well, that's exactly what the space station is doing. Except, instead of distracting itself, it uses orbital velocity. Less elegant, but arguably more reliable. Now the space station has to stay at exactly the right speed for this to work. Too slow and it stops missing. It stops chasing the curvature and starts actually falling onto Earth. We see this with old satellites. Their engines fail, the orbit degrades, and they eventually fall back down and burn up on re-entry. So the space station isn't in zero gravity, it's in a constant state of falling, and so are the astronauts inside it, and the equipment, and the coffee cup. Everything is falling at the exact same rate. So, relative to each other, nothing moves. Things just float. From their frame, they're still. Everything is calm. The coffee cup stays where they left it. But from the outside, they're hurtling around the Earth in perpetual freefall. Both observations are completely correct. Einstein turned this into a thought experiment that still messes with people. Imagine you're sealed inside an elevator with no windows. You feel your normal weight. Now, are you standing on Earth? Or is this elevator accelerating upwards at exactly 1 g in empty space? Run any experiment you want. No measurement you take from inside that elevator distinguishes between the two. It's the car with no windows, formalized. But here's where it gets philosophically interesting. Step into a different frame, a different observer, a different state of motion, and the measurements change. Time passes at a different rate. Distances are different. The same event observed from two different frames produced two different sets of correct results. Both scientifically valid. What you observe depends on where you're standing. And that's not a limitation. That's how reality works. So what's your frame in software? Your team size, your traffic, your product maturity, whether you're pre-product market fit or running infrastructure for millions of users, your domain, your org structure. These are the parameters of your frame, and they determine what the right answer looks like from where you're standing. And here's a failure mode I want to name: frame importing. You read a major tech blog. You go to a conference talk by a staff engineer at a company with thousands of engineers. You watch a YouTube video. You hear a principle, it makes complete sense, it's clearly correct, and you bring it back and apply it to your two-person startup. Their measurements are correct for their frame. The mistake isn't following their advice. The mistake is not doing the translation, not asking what were the parameters of the frame where this was measured, and what's the gap to mine. Let me give you two examples. TDD, test-driven development. In a stable domain with a well-understood requirement, this is good practice. You know what the thing should do. The test clarifies the contract. The code fulfills it. You get fast feedback, you ship with confidence. In early stage product development, when you're pivoting every 3 weeks and you don't yet know what you're building, TDD can be an expensive anchor. You write tests for behavior you're about to throw away. You hesitate to change things because the tests break. The practice that made you faster in one frame is slowing you down in another. Same principle, different frames, different measurements. Let's look at another example. There's a famous quote from Donald Knuth, one of the foundational figures in computer science. Premature optimization is the root of all evil. It gets cited in code reviews constantly. And it's right, in most frames. But notice something. The word premature is already doing framework. Premature relative to what? Relative to when? In high-frequency trading, optimizing from day one isn't premature. It's the job description. In embedded systems, memory constraints aren't a future concern, they're a current one. And even beyond timing, what to optimize and how are also frame dependent. Optimize for latency in one domain, memory in another, developer velocity in a third. Optimization isn't a single thing, it's a direction. And the right direction depends entirely on your frame. Knuth wasn't wrong, he was just measuring from a specific frame and giving you a correct measurement. The mistake is importing it without doing the translation. Which brings me to the thing I actually want you to take away from this. It depends has a reputation. People hear it as a dodge, as I don't know, as the consultant's way of not committing to an answer. It's not. It's the most precise thing you can say. When you say it depends, you're saying, this is a frame-dependent measurement, and I need to know your frame before I can give you the right number. That's not avoiding the question. That's asking for the information required to actually answer it. The architect in the opening wasn't wishy-washy. They were right in every single time. Microservice, then monolith, then platform. Each answer was correct the moment the frame was specified. The question wasn't ambiguous, the frame just kept changing. Remember what I said about the speed of light. Not everything in software is frame dependent. Just like in physics, there are principles that hold in every frame. And part of the skill is knowing the difference between those and the implementations that only look universal. Laws are invariant. Measurements are frame dependent. In software, principles are invariant. Implementations are frame dependent. Performance matters in every frame. What acceptable latency looks like? Frame dependent. 100 milliseconds is imperceptible in some contexts and catastrophic in others. Caching is always worth considering in every frame. Whether you actually build a cache layer and what you cache, frame dependent. Depends on your read-write ratio, your infrastructure, where your actual bottlenecks are. Here's the heuristic. When someone says, always do X, ask whether X is a principle or an implementation. If it's a principle, they're probably right. If it's an implementation, ask which frame they measured it in. If you're in an architecture argument that feels like it's going nowhere, try stating your frames explicitly. Both of you. Team size, traffic, product stage, what you're optimizing for. You'll often find you're not actually disagreeing about the right answer. You're measuring from different frames and getting different numbers. Both correct. Once you see that, the argument changes shape completely. Sometimes it dissolves entirely. Not always, but more often than you'd expect. So, software relativity, the it depends principle. There is no privileged frame in software architecture. Your experience inside your frame is complete, consistent, and correct, just like the engineer floating in orbit. And just like them, you can't feel the frame from inside it. It depends is not a dodge. It's the physically accurate answer. So I want to know, what's the most confidently stated always do X advice ever received that turned out to be completely frame dependent? Drop it in the comments. I'm expecting good ones. And if you enjoyed this, please subscribe. There are more laws where this came from. And remember, physics is awesome, software is human. See you next time.